Hello everyone, my name is Julie and today we're going to be talking about quadratic equations and more specifically extremum problems. I've heard that someone needs our help, so let's meet Farmer Lore.
Hi, Laura.
Oh, hi! I didn't see you there. Hello, my name is Laura and welcome to my farm. This is Bella, one of the cows I have in the stable. But there's just one problem. They don't look that happy. I think it's because they have to spend every day in the stable. That's why I went shopping and bought a piece of wire. So I would like to use this to fence off a section of land right next to my stable where the cows can go outside. So I bought 720 meters of wire. I want to use this to fence off a biggest area possible. And that's why I need your help. I need you to help me figure out the dimensions. Using 720 meters of wire, how long and how wide can I make my field? With your help, hopefully my cows can finally go outside. See you soon!
So this is our first extremum problem. To solve this problem, we are going to use a step-by-step plan consisting of 7 steps. Now, let's first understand the problem. So, Laura wants to fence off a rectangular area of land for her cows, and to do this, she has bought 720 meters of wire. Now, the piece of land that she wants to fence off is right next to her stable, so that means that one wall of her stable is already part of this rectangular field. Now, she wants to know the maximum area possible. So, I've made a sketch to make it easier for you. So you can see here in red is the wall of this table. So you can see it's already part of the field. And in black you can see the wire that she uses to fence off her land. Now our first step is to choose the variables. Now Laura has asked us to calculate the area. Now how do we do this? To determine the area we have to multiply the length with the width. So in this case, we don't know what the length or the width is, so these are our two variables, and we're going to represent them each with a letter. So we're going to use L for length and W for width. Let's put them on our sketch as well. So you can see we have the width twice and the length only once because we don't need any wire to fence off the part where the wall of the stable is. Our second step is to determine the target function. Now, what is the target or the goal? In this case, we have to find the area. And like we said in the previous step, how do we calculate the area? We multiply the length by the width. So our target function, in this case, is A for area. A equals L times W. Now our third step is to determine the link between variables. So we have our two variables, we have the length and the width. And to determine the link between them, we also have to look at all of the other information that we have. In this case, we also know that Laura has bought 720 meters of wire. Now, the goal here is to write one variable in terms of the other. So we're going to leave the width, so W the same, and we're going to change up the length. So let's look at our sketch once again. We know that we have 720 meters of wire, and we need this to fence off the field, and the field consists of the width twice, so on the left and on the right, and the length just once. So if we can write the length like this, 720 minus 2 times W. So 720 meters minus 2 times the width that we have to fence off. So you can see it here on the sketch as well. Now step 4 is to then write the target function in terms of one variable. So our original target function was A equals L times W, and our variables were originally the length and the width, but in the previous step we changed it up a bit. So now our variables are the width, so W, and for the length we found that it is 720 minus 2 times w. So now let's replace the L in our original target function with the variable that we found, and then we get this new target function. A of w equals 720 minus 2 times w times w. Now if we calculate this further, this is what we get, negative 2w squared plus 720w. This is our new target function. Step 5 is to then determine the extremum. Our target function, which you can see here, is a quadratic function, and the graph of a quadratic function is a parabola. Now, there are two types of parabolas. We have a parabola opening downwards. This is the case when a is smaller than 0. And we have a parabola opening upwards. This is the case when a is larger than 0. So in this case, a equals negative 2, so smaller than 0, so that means that we're dealing with a parabola opening downwards. So the extremum that we're looking for is a maximum. Now where can we find this? We need to determine the vertex of our parabola. Now the coordinate of the vertex is alpha, beta. Now, how can we find alpha and beta? Alpha equals negative b over 2a. So let's fill this in. So then we have negative 720 over 2 times negative 2 equals negative 720 over negative 4. And then we find that alpha is 180. So now we have to find beta. Now, how can we do this? We need to fill in alpha in our function. So we're going to change the w by the x value that we found, so our x coordinate or alpha. So that means that beta is a of 180, so equals negative 2 times 180 squared plus 720 times 180. And then we find that this is 64,800. Now what have we found? We found that alpha is 180, so alpha is our x value. So in this case, this is the width of the field, so W, the width, and beta is the maximum area. So step 6 is to formulate an answer. So let's take a look at the information that we found. We know that the width, we determined this in the previous step, the width is 180 meters. The length is 720 minus 2 times w. So let's fill in our value for w, and then we find that the length is 360 meters. The maximum area, we also found this in the previous step, equals 64,800 square meters. So now let's formulate our answer. The maximum area of this field is 64,800 square meters, and we can achieve this at a width of 180 meters and a length of 360 meters. So now our last step, last but definitely not least, is to check your answer. So we know that Laura has 720 meters of wire, and she needs this amount of wire to fence off the length once and the width twice. So if we fill in the values that we found, we can see that this is correct. But this is not enough. Laura asked us to find the maximum area possible. So we said this is 64,800 square meters. So that means if we change the value of the width or the length, we can never have a field that is bigger, which is larger than 64,800 square meters, because then our answer wouldn't be correct. So to check this, we're going to change up our values. So let's say that our width, in this case, is only 170 meters, so smaller than what we found. Then our length is 380 meters, and our area is 64,600 square meters. So as we can see here, this is smaller than the answer that we found, so this is good. Now let's change it up one more time. So we're going to take a width of 190 meters, so larger than what we found. Then the length becomes 340 meters, and the area that we find is 64,600 square meters. This is again smaller than our answer. So that means that we can assume that our answer is correct. So let's give our answer to Laura and see what she has to say.
You guys did a great job. Now I can finally start to fence off my field. But while you're here, I need another favor. To earn a bit of money on the side, I want to open a small web shop to sell my t-shirts. On the t-shirts, there are all kinds of different farm animals. The t-shirt I have on right now is one of my own t-shirts. But you know that mathematics is not my strong suit, and that's why I need your help. I need you to help me figure out how to make the most money possible. So I need you to help me figure out how many t-shirts I should sell and at what price. I've already written down all the details for you and sent them to you. So take a look. Bye!
Alright, so we're going to move on to our second extremum problem. To solve this, we're going to use our step-by-step plan once more. Alright, so let's first understand the problem. Laura has sent over all of the details, so let's look at them together. So every month, Laura sells 100 t-shirts on her web shop, and she sells them at 20 euros per t-shirt. Now she has done some research, and the research has taught her that every time that she reduces the price of a t-shirt by €1, she can sell 10 additional t-shirts. Now, she wants to know at what price she should sell her t-shirts in order to maximize her revenue, so to make the most money possible. So our first step is to choose our variables. Now, how can we calculate how much money she'll make? To do that, we need to know obviously the price of her t-shirts and the number of sold t-shirts. So these are our two variables. So the price per t-shirt, we're going to represent this with the letter P, and the number of sold t-shirts is in this case Q. So these are our two variables. Now our second step is to determine the target function. Now the target here is to calculate her maximum revenue. So in this case, we're going to represent the revenue by the letter O. So O equals P times Q. So the price per t-shirt multiplied with the number of sold t-shirts. That's how we figure out how much money she'll make. Now, once again, our third step is to determine the link between the variables. So we have our two variables, but like we said previously, we need to also look at all of the other information. So we know that originally she sells 100 t-shirts a month at $20 a piece. And research has taught her that every time that she reduces the price by €1, she can sell 10 additional pieces. So that means if she reduces the price once, so she sells them at €19 a piece, she can sell 110 pieces. If she sells them at €18, so that means that she's reduced the price twice, she can sell 120 pieces, and so on. Alright, so now let's change up our variables. So we need to look at the price per t-shirt. So the price originally is $20, but she reduces the price by €1, but we don't know how many times she should reduce the price. So we're going to represent this with X. So our variable, the price per t-shirt, becomes 20 minus X, and X being the number of times that she reduces the price. So we know that the number of sold t-shirts is 100 t-shirts, but every time she reduces the price, she can sell 10 additional t-shirts. So that means that our next variable becomes 100 plus 10 times X. So 10 additional pieces per time she reduces the price. Now let's write our target function in terms of one variable. So our original target function, you can see it here, is O equals P times Q. Our variables that we found in step 3 are now the price per t-shirt is 20 minus X, and the number of sold t-shirts 100 plus 10 times X. So let's replace P and Q in our original target function by our new variables, and then this is what we get. So O of X equals 20 minus X times 100 plus 10X. So let's calculate. Then this is our second step, so 2000 plus 200x minus 100x minus 10x squared. We get this result by using the distributive property, and this is the standard form of our quadratic function. O of x equals negative 10x squared plus 100x plus 2000. This is our new target function. So again, step 5, we have to determine the extremum. So let's see here. A equals -10. So we're again dealing with a parabola opening downwards. So we're dealing with a maximum that we have to find. So again, the coordinate of the vertex is alpha, beta. So let's calculate both of them. So alpha, like we said previously, is -2 over 2 times a. So let's fill in the values that we have in the quadratic function. Then we get -100 over 2 times -10, and this equals 5. So we know that alpha is 5. Now, for beta, we have to fill in 5, so the value of alpha, in our function. So now we have to calculate over 5. This equals -10 times 5 squared plus 100 times 5 plus 2,000, and this equals 2,250. So now what have we found? We have found that the x value, so the value of x is 5. And like we said, x is the number of times the price of a t-shirt was reduced by €1. So we know that the number of times is actually 5. Beta is then the maximum revenue. So now let's formulate an answer. So we know that the number of times the price of the t-shirt was reduced by €1. That was represented with x, and we found that x is 5. The price per t-shirt, we said, was 20 minus x. So let's fill this in, and we find that the price per t-shirt is €15. Now we have to calculate the number of t-shirts sold, so this was Q, and for Q we had 100 plus 10 times x. Let's fill in x, and we have 150. Our maximum revenue, that was beta, that we found in the previous step, was €2,250. So if Laura sells her t-shirts at €15 per t-shirt, and she sells 150 t-shirts, she'll earn a maximum of €2,250. Like we did previously, we are going to check our answer. So we know that every time the price is reduced by €1, she can sell 10 additional pieces. So at €19 a piece, she can sell 110. At 18, she can sell 120 t-shirts. And we found that at €15, she can sell 150 pieces. Now, she asked us to determine how she could make the most money possible, and we found for the price per t-shirt and the number of sold t-shirts, the values that you can see on the PowerPoint here. So that means that if we change up these values, that we can never have a revenue that is larger than the answer that we found, because then we've made a mistake somewhere. So we're going to change up our values. So let's say that the price per piece is €14. Then that means that the number of sold t-shirts is 160, and the revenue is then €2,240. So that is smaller than what we found, so that's good. Let's change it up one more time. Let's say that the price per t-shirt is €16. Then she can sell 140 pieces and make €2,240. This is again smaller than what we found. So we can again assume that our answer is correct. So let's report back to Laura and see if she's happy with our answer.
Thanks to you! My cows have room to go outside, and I know at what price I should sell my t-shirts. Thank you so much for your help. Bye!
Thank you so much for listening. Bye!